Hello everyone, welcome to the fourth video of the unit Direct and Inverse Proportion. In this video we are going to see what is inverse proportion. So in previous videos we learnt about direct proportion. What is direct proportion? When two quantities are related, when one quantity increases causes the other quantity also to increase, or if one quantity decreases that causes the other quantity also to decrease, then we can say that those two quantities are in direct proportion. So now we'll see what is inverse proportion. Okay, so in this video we are going to see what is inverse proportion, example problems and exercise problems. Okay, first we'll see what is inverse proportion. When two quantities are related, increase in one quantity leads to decrease in other quantity. That is, when two quantities x and y are related, when the quantity x increase, the quantity y will be decrease. Increase in one quantity leads to decrease in other quantity, or decrease in one quantity leads to increase in other quantity. Okay, then we can say that those two quantities are in inverse proportion. So to understand this, first we'll consider a situation. The following table shows the number of workers and the number of days to finish the construction of water tank in the school. Here, the two quantities which are compared, which are related, are number of workers and number of days to construct the water tank in the school. When number of workers increased, what happened to the number of days to complete the work? When more number of workers are doing the work, it will take less number of days to complete the work. Okay, when less number of people are working, it will take more days to complete the work. Suppose if two people are doing that work in 40 days, here two people are constructing the water tank in 40 days. If two people work, it will take 40 days to construct the water tank. But if four people works, it will take 20 days. Okay, so when you increase the number of people, number of days will decrease. So these two quantities are in inverse proportion. Okay. So in this situation, the two quantities, namely number of workers and number of days, are related to each other. And we can observe that when number of workers increase, number of days to finish the job decreases. Right. Now what we can do is we'll consider the number of workers as x and number of days as y. Okay. Then we note that product is always same. When you see here, when you take any x and y, the product is always same. That is, x into y is equal to 2 into 40, which is 80. Right, here x into y is 80. When you take the next column, 4 into 20, x into y is 4 into 20 is 80. 5 into 16, 16 into 5, 6 5s are 30, remaining 3, 1 5s are 3, 1 5 is 5, 5 plus 3, 80. So here also the product is 80. Here also 10 8s are 80. So in inverse proportion, when you take x and y, you will get constant. So xy is equal to k. This is in case of inverse proportion. What we have seen in direct proportion, x by y is equal to k, constant. Right, this is in case of direct proportion. But in case of inverse proportion, x into y is equal to k. So in case of direct proportion, when you take any two x value, that is x1, x2, x1 by y1 is equal to x2 by y2. Here xy is equal to k. So when you take x1, x2, x1, y1 is equal to x2, y2. Okay, in case of inverse proportion, xy is equal to constant. Okay, when two quantities x and y are compared, when those two quantities are in inverse proportion, x into y is equal to k. So when you take any two different values of x1 and y1, x1 and x2, corresponding to x1 you will be having a value y1, and corresponding to x2 you will be having a value y2. So here in case of inverse proportion, x1 y1 is equal to x2 y2. Okay. Now we'll see what is direct proportion and what is inverse proportion. So now recall what in case of direct proportion we'll have and what we'll have in case of inverse proportion. Okay, when the quantities are in direct proportion, x by y is equal to k, or x1 by y1 is equal to x2 by y2. Okay, in case of inverse proportion, xy is equal to k. So you will get x1 y1 is equal to x2 y2. Using this we are going to solve the problems. Okay, and direct, when we can say two quantities are in direct proportion, increase in one quantity causes increase in other quantity, or decrease in one quantity causes decrease in other quantity, then we say that those two quantities are in direct proportion. And when we can say two quantities are in inverse proportion, decrease in one quantity causes increase in other quantity, or increase in one quantity causes decrease in other quantity. Okay, I hope you understood this. Using this, now we'll complete this table. Okay, we have to find out in which proportion these table belongs to. Find the type of proportion. We are going to find which type of proportion is this. Okay, here number of chocolates and price in rupees is compared. Okay, so think, when you increase number of chocolate, what will be happen to the cost of the chocolate? So when you increase number of chocolate, the cost will also increase. So in which proportion it is? It is direct proportion. Okay, so here when you increase number of chocolates, the cost of the chocolate, that is price in rupees, will also increase. Here what they have given is cost of one chocolate is 5 rupees. So if you are paying 10 rupees, then how many chocolate you have bought? You have bought 2 chocolates. Okay, cost of 2 chocolate is 10 rupees. Cost of one chocolate is 5 rupees. What will be the cost of 3 chocolate? Cost of 3 chocolate is 3 into 5. Right, so 15. Cost of 4 chocolate is 4 5s are 20. What will be cost of 5 chocolate? Cost of 5 chocolate will be 5 into 5, 25. What will be the next column here? Here we have 1, 2, 3, 4, 5. The next one will be 6. Right. So 6 5s are 30. And this quantities are in direct proportion. Now see the second table. In the second table, number of workers and time is compared. Number of workers and time to complete the work is related. One worker is completing it in 20 minutes. Okay, 20 hours. The same work, if two people are doing, in how many hours they will complete? When one worker is doing, it takes 20 hours to complete the work. When two workers are doing, what will be the time taken to complete the work? So we know that x1 y1 is equal to x2 y2. Here when number of workers increase, time will reduce, right? When number of workers to do the job increases, time taken to complete will decrease. So here this is in inverse proportion. Okay, in case of inverse proportion, we have x1 y1 is equal to x2 y2. So these are x values and these things are y values. So we have x1 as 1, x2 as 2 and y1 as 20. So 1 into 20 is equal to 20 into x. We don't know what is here, so we'll take that as x. So 1 into 20 is equal to 20. Sorry, 1 into 20 is equal to 2 into x. Okay, this is 2, right? 2 into x. So to find out x, we have to take this 2 to other side. Here 2 is in multiplication. When you take this to other side, it will go in division. So 1 into 20 by 2. 1 2 is 2, 10 2s are 20, right? So for 2 workers it will take 10 hours. For 4 workers it will take 5 hours. Okay, what will happen for 5 workers? So we know that 1 into 20 is equal to 5 into x. Right, this is nothing but it is like a equation. When you interchange LHS and RHS, the equation is not going to change, right? So 5 into x is equal to 1 into 20. x is equal to 1 into 20 by 5. 1 into 20 is 20. 20 by 5 is 1 5 is 5. 4 5s are 20. So x is equal to 4. So when number of workers is 5, time in hour is 4. Okay. Then when they can complete the work in 2 hours. How many people can complete the same work in 2 hours? Okay. We need to find out this one. So we know that 1 into 20 is equal to, now take number of workers as x. X into 2. Right. So we have to find out x. So take this 2 to the other side. 1 into 20 by 2 is equal to x. Here x is the number of workers to complete the work in 2 hours. Okay. So 10. 10 workers can complete in 2 hours. So how many workers can complete in 1 hour? 20 workers can complete it in 1 hour. Okay. So this is also in inverse proportion. Okay. Now we'll move to this one. Read the following examples and group them into 2 categories. So here they have given different examples. We have to group them whether it is direct or inverse proportion. Okay. So see the first one, number of notebooks purchased and its cost. So what it will be, direct or inverse proportion? Here 2 quantities compared are number of notebooks and cost of it notebook, right? So when number of notebook increased, what happened to the cost? Cost will also increase. Okay, here increase in one quantity causes the other quantity also to increase. So this is a direct proportion. Okay, now see the second one, food shared by number of students to the fixed quantity of food. Okay, so here the quantity of food is fixed. Okay, they have fixed the quantity of food. So now what they are comparing is food shared by number of people and the amount of food. What will happen when number of people increased? Amount of food shared by the people will become less, right? Suppose if we have only 4 idlis, okay, now count of idli is fixed and there are 2 people. They have to divide these 4 idlis equally. How they will divide? Each person will have 2 idlis, right? Suppose the number of idlis remain same, and if number of people who is sharing that idli is increased, that is if another 2 people joined. Suppose if there are 4 people will divide 4 idlis each one, right? So 1 for each people. When 4 idlis, number of idlis taken by each people is 1. When 2 people are there, number of idlis shared by each people will be 2, right? So when number of people increased, the amount of food shared by them will decrease. Okay, so here second one is in inverse proportion. Now see the third one, number of boxes of same size and their weight. So when we have many number of boxes, here quantities compared are number of boxes and weight of that boxes. Okay, all the boxes are of same size. When number of boxes increase, what happened to their weight? Since all are of same size, when you increase number of boxes, the weight will also increase. So here the third one is in direct proportion. Now see the fourth one, number of uniforms to the number of students. So when number of uniform increases means number of students is also more there, right? When number of students increases, number of uniform will also increase. So this is also in direct proportion. Now fifth one, speed of a vehicle and the time taken to cover the fixed distance. So here speed of the vehicle and time taken to cover fixed distances compared. Okay, here related. Here distance is fixed. If we are driving the vehicle in more speed, we will reach soon, right? If we are going slow, it will take time to reach the same distance. So when speed is increased, time will reduce. When speed is decreased, time will increase. So here in which proportion is this? This is inverse proportion. Okay. This is how we have to find out whether the given quantities are in direct or inverse proportion. Okay, now we'll move to example problems. Example 4.5. Okay, 60 workers can spin a bale of cotton in 7 days. In how many days will 42 workers spin it? So they are spinning the bale of cotton. Okay, 60 workers can do that in 7 days. So how many days will 42 workers? If the same work is done by 42 workers, how many days they will take to to spin a bale of cotton? Okay, so here when number of workers increased, the number of days will decrease, right? So when more number of people are doing the same work, the number of days to complete that work will decrease. So here the quantities are in inverse proportion. Since we don't know how many days will it take for 42 workers to spin it, we'll take it as x. Let x be the required number of days. Okay, given that 60 workers can spin a bale of cotton in 7 days. And we know that a decrease in number of workers lead to increase in number of days. So here 60 workers is decreased to 42 workers, right? When the number of workers is decreased, then that will lead to the increase in the number of days. So they both are in inverse proportion. And we know that for inverse proportion, x1 y1 is equal to x2 y2. Now you have to make a tabular column. Number of workers and number of days. Number of workers as x and number of days as y. When 60 workers doing, it will complete in 7 days. And when 42 workers doing it, we don't know how many days. We have taken it as x. So 60 into 7 is equal to 42 into x. We'll take it as 42 into x is equal to 60 into 7, which is we are interchanging the LHS and RHS. Okay, so we need to find out what is value of x. So x is equal to, so keep this x as it is, take this 42 to the other side. When you take 42 to the other side, here 42 is in multiplication. When it go to other side, it will be division. Okay, x is equal to 60 into 7 by 42. 60 into 7 by 42. 1 7 is 7, 6 7s are 42. 1 6 is 6, 10 6 are 60. Okay, so value of x is 10 days. Okay, so 42 workers will spin the bale of cotton in 10 days. Okay, here it is 60 into 7 by 42. Okay, now we'll move to the second example. Example 4.6. The cost of 1 box of tomato is 200 rupees. Vendor had money to buy 13 boxes. If the cost of box is increased to 260 rupees, then how many boxes will he buy with the same amount? So, cost of 1 box of tomato. If the cost of 1 box of tomato is 200 rupees, vendor had money to buy 13 boxes. Okay. Suppose if the cost is increased to 260, how many boxes of tomato will he buy with the same amount? First, we need to find out the money vendor had. Okay, since he had money to buy 13 boxes and cost of 1 box is 200, vendor amount of money with vendor, that amount of money that vendor had will be 13 into 200. How much is this? 0 0, 13 2s are 113 is 13, 2 13s are 26, 2600. So he had 2600 rupees. Okay, with 2600 rupees, if cost of 1 box is 260 rupees, how much box he might have had? Here cost of 1 box is 200 rupees. So increased cost is 260 rupees. We don't know how many number of boxes vendor bought when the cost of the box is 260 rupees, right? So we'll take it as x. Let x be the number of boxes bought by vendor. As cost increases, number of box will decrease, right? When cost of a box increases, with the same amount, if he has to buy number of boxes, it will decrease. So cost of box increases leads to number of boxes to decrease. So here the quantities are in inverse proportion. Okay, so therefore x1 y1 is equal to x2 y2. We have to take cost as x and number of boxes as y. Number of boxes as x or cost as y. When it is 13, it is 200. Cost of one box is 200. When it is x, the cost of that box is 260. Okay, when it is x number of boxes, cost is 260 rupees. So 13 into 200 is equal to x into 260. Okay, so 13 into 200 is 2600. Okay, 2600 is equal to x into 360. Here we are in this step we are exchanging the LHS and RHS. So we need the value of x. So take 260 to the other side. 13 into 200 by 260. Okay, 0 0 will get cancelled. 113 is 13, 2 13s are 26, 1 2 is 2, 10 2s are 20. Okay, so x is 10. So with the same amount, Vendan had bought 10 boxes. So x is equal to 10. Therefore, he can buy 10 boxes for same amount. Okay. So same thing. How we have done in direct proportion. Similarly, we are doing it in inverse proportion with this formula. Fine. In case of direct proportion, we could have used x1 by y1 is equal to x2 by y2. So in case of inverse proportion, we have to use x1 y1 is equal to x2 y2. This is how you have to do the problems. So I hope you have understood this video. Using this as model problem, try to solve this exercise 4.2, fill in the blanks. First one, second one, and objective type question 10th one and 11th one as your homework problem. Okay, we'll meet in next video. Thank you.